Welcome, everyone, and thank you for joining us today. My name is Jenny Zell, and I'm the moderator of today's webinar. This is the first of two training sessions on headless.cms. In today's session, we'll be showing you how to take advantage of all the features of Next.js to build a top-notch Jamstack application that has better performance, higher security, and scales quickly. This webinar will be recorded, and it will be sent out after the webinar is over. We'll also have a Q&A session at the end with our speakers, so if you have any questions during the webinar, please feel free to add them to the chat box as we go along. Today's speakers are Freddie Montes, Senior Front-End Developer, and Ivor Padilla, Front-End Developer, both at dotCMS. And with that, I'd like to pass over to Freddie.
Hello everyone, and thank you for joining us today. We're going to be exploring a super fast Jamstack website that we built using dotCMS APIs and Next.js. dotCMS is a hybrid CMS that offers the advantages of a headless with the ease of a traditional CMS, making it ideal for both marketing and IT teams alike. dotCMS offers a huge set of rich features, including drag and drop capabilities, custom layouts, templates, workflows, content types, among others. One of the key features of dotCMS is that it allows content editors not only to edit the content in a page, but also the layout with no code needed. For us, front-end developer, this is really powerful because we can allow marketers to create and edit the page with the layout they need at any time with no extra code from our side. Next.js is a React framework to build fast, static, and dynamic websites. It's the most widely used React framework to date, and it offers pre-rendering, static generated pages, server-side rendering pages, file system-based routing, automatic code splitting, and ready for production and enterprise-graded apps. If you want to know more about Next.js, I really recommend you to visit nextjs.org/learn. This site will guide you through the concept of Next.js with a nice interactive tutorial. We're building an e-commerce website managed entirely with dotCMS. Everything you see from the layout to the content can be modified from our CMS. So as you can see here, we have a fully functional e-commerce website that adds category and have a product listing and have a navigation. So all these pages are built with Next.js, getting the data from dotCMS, the content, the layout, the images, etc. If we go to a product detail page, you can see it's pretty fast. We can go back to the store. We can go to a category. We can filter by tags and go to a product detail page from here. What are we using? Okay, we're going to use dotCMS and its APIs. We're going to use React, hooks, context. We're going to use Next.js, and we're going to use GraphQL. dotCMS Layout API. This REST API enables you to retrieve all the elements of any page in your dotCMS system and include all the elements used to display the page. Includes the site, page, template, containers, content, and of course the layout information, row, column, width, offsets, classes, etc. Now let's go to dotCMS and edit a layout so we can see how the response works. So we have this page that only have one row and one container. Let's go to the layout editor and let's do something more like a typical web page layout. So let's add 3 boxes of 4 columns each. And let's add 2 more of 50% and 50%. Don't forget about the containers. Let's add the default container to all of them. And let's save this. Now that everything is saved, let's go back to edit our page. You can see now that we have the first row we created, full length. We have a second row with 3 boxes, and we have a third row with 2 boxes of 50% each. Now, let's see the response API that represents this page. We just need to click this little API button and we'll see the whole response. It not only includes the layout, but all the information of the page. But for now, let's focus on the layout information. So we have a layout property that includes the body. The body is where it's representing all the rows and boxes in the page. So if we go to this page in particular, we can see that our rows array contains 1, 2, and 3 rows. If you expand the first one, we can see that this is the first column that have 100% of width, that have a 12 column width, and that have no offset because it start in the column 0. So you can see that this is our first row right here. Then if we go to the second one, you can see that have an array of boxes, which is 1, 2, and 3. That represents 1, 2, and 3. And the first one, it's 33%, 33%, and 33%. But also they have the columns width, which is 4, and they have offset. For example, the first one start in 0, but the second one start on 4, and the third one start on 8. And that's how we represent rows and columns in a dotCMS page. We have a layout object that we need to turn into a page. The idea is to create all the necessary HTML markup and CSS to render the page accordingly. You can use anything you want: CSS grids, Flexbox, Bootstrap. For this webinar, we use Reflex Grid, a lightweight responsive Flexbox grid with cross-browser support, and of course, React. Now, let's see some code. We create a React component that receive the body property object from the layout. Then we iterate over each row, and for each, we render the HTML we need. In this case, we render a section HTML tag with an ID, and we also are passing the class name that is coming from the row in dotCMS API. In dotCMS, users can create rows and add very specific classes for extra styling. Then we create a row container React component that will take the row as prop. And inside this component, we iterate over the columns coming from the row object. And again, we render the HTML accordingly. Then for each row, we create a column container component that takes the column as a prop. In this column container, we can get from the props the column width, the column offset, and the column class, because users can also add classes to columns. And also the containers, which are the dotCMS containers inside this column. Then we can pass to this column component the width and the offset. In this column component, we need to create and pass the class name to the div in order for our CSS framework to render it accordingly. Now that this is all done, let me show you how the result of the tree of React components looks like for the rows and columns on a page of dotCMS. So we have this tree. Basically, we have a layout header and we got the grid. The grid contains the first row component, and then we have a column component inside. Then we have a second row container that contains 3 columns, 1, 2, and 3, and that's how it looks like inside a React components tree. Okay, now we know how to render the grid of a page using our layout API. And what about the content? In dotCMS, content or contentlets are instances of a content type, and you can have as many as you need. Let's take a look how this works. Let's go to our content type portlet and let's look for our banner content type. Here you can have as many fields as you want. For example, we have title, we have styles, we have image, we have caption, and you can keep adding from the sidebar. Now, if we go back to our example page, let's add a banner to this page. So we go to a container and we click add content. Then here we filter by the banner content type. And let's add the second one, Costa Rica beaches. So we add the banner. And now if we look into the API of the page, we can see that in the first container, this one right here, we have contentlet and we have a UUID, and inside we have the information of the banner that we just add. We got the title, which is Costa Rica beaches. We got a caption. We have the image information and all of the other fields that are in the content types, but also some system fields. Okay, but how do we know where the banner shows up in the page? In our layout information, we not only have the information to the width and how many columns do we have, we also have a reference to the containers inside that column. We have the identifier and we have the UUID. Using that reference, we can go to the containers property, look for the identifier of the container, and then inside that one, we check the contentlets property and we find the UUID1, which is the one referenced in our column, and inside we get an array of contentlet because of course a container can take more than one contentlet. In this case, we get the contentlet from the banner we add to the page. We get the title, we get the image, and we get all the other fields from the content type, including the content type name. With the name of the content type, we can create a React component that will receive the contentlet as prop in order to render the UI or the look and feel of a banner contentlet inside the page. So at the end, when you're rendering row, columns, containers, and contentlets, your HTML or your React components tree will look like this. In summary, dotCMS Page API gives you all the information for you to render the page. Rows, columns, containers, and of course contentlets. With this information, you'll be able to create a React tree of components or any HTML for that matter that you want for render the look and feel of your page. Let's talk about Next. The first thing we need to know about Next is how Next handles pages. A Next page is a React component exported from a file in the page directory. By default, Next.js pre-render all their pages. This means that Next generates HTML for each page in advance, instead of having it all done by client-side JavaScript. Pre-rendering can result in better performance and SEO. Each generated HTML is associated with the minimal JavaScript code necessary for that page. When a page is loaded by the browser, its JavaScript code runs and makes the page fully interactive. This process is called hydration. Let's say we create an about.js file inside the page folder. Then, to create a page, we just need to create a functional component. It could be functional or it could be a class component, and export it by default from that file. That way, we just create a page in Next. Next.js routing. By default, each page is associated with a routed based on its own file name. This means that if you create an about.js file inside the page folder, it will be accessible for your server/about. The same result if you create page/about/index.js. Based on this information, I guess the question is popping into your head is, do I have to create a page in dotCMS and in Next? And the answer is no. Page and folder will live in dotCMS, and Next will just fetch it from there in order to render it. And we're doing this because we want to give content creators all the freedom we can. We want them to be able not only edit pages, but also create new ones with no code whatsoever. To achieve this, we're going to use Next.js dynamic route. Defining routes by using predefined path is not enough for this case, because we want to give content creators the freedom of create pages in dotCMS, and we don't have a way to know that pages in advance. To create a dynamic route in Next.js, you just need to enclose into brackets the file name of the page. And then you create the components as usual. Any route like slash post slash one or slash post slash abc will match the file we just created, brackets pid.js. And the query that we're getting from the use router hook provided by Next.js will hold or will contain the one and the ABC string and will be accessible from within the component. Along with dynamic routes, we'll be using a feature called catch all routes. Dynamic routes can be extended to catch all path by adding three dots to the file name, also between brackets. With this approach, any route like post slash abc, but also post slash abc slash def, etc., will be matched to the file post slash three dots pid.js. And the query object from the router, instead of returning just a string with one segment, it will return an array of a string with any amount of segments you have in the URL. This is the key feature from Next.js that allows us to render any page at any level from dotCMS. We talk about how Next.js pre-rendered all the pages by default, but we didn't say how. Next.js has two forms, static generation and server-side rendering. The key difference is when the HTML for the page is generated. For static generation, the HTML is generated at build time, and it will be reused on each request. In server-side rendering, the HTML is generated on each request. With that in mind, we decided to go with a static generation. Next recommended, the pages in our site don't change that much. Also, when a page changed, we were able to fetch that change data in the client using dotCMS APIs. And a feature from Next.js, which is still on beta, called incremental static regeneration. We will talk about that when we see the code to generate the pages. To build our pages, we're going to do a three-step process. Number one, we're going to fetch all the pages from dotCMS. We're going to get a list from all the pages in dotCMS. Number two, we're going to use the dotCMS page API to get the page object for each item in the page list. And finally, we're going to generate a Next.js page with the page API object we got from each page on the list. First, let's see the structure of our site in dotCMS. So let's go to the dotCMS portlet browser. And here we can see we have a bunch of folders. We got activities, they have an activity detail page, we have a blog, they have an index and a blog detail page. We got store, which have, of course, an index, cart, and our example page, and then they have a category page, a category folder with other categories with their respective index page. So what we want to do is we want to catch any route in Next. Anything. It doesn't matter where it is. We want to catch that in Next because with that route, with that URL, we'll be able to fetch the page in .cms. So to do that, the first thing we need to do is we need to create a catch-all dynamic route in the page folder. We need to create a file that uses the name slug. We need to prefix it with the three dots and enclose it into brackets. And of course, .js as file extension. This file will match any route we throw to it. So a slash store or even slash store slash category slash no, any level, or even a slash destination. So any route we try to go in our Next.js app will be matching this particular file. So we will have one file to rule all our pages. We already talked about how to render a static page and how to show content. You just export the React component on the page file. But what about data fetching? So for data fetching, we're going to use two functions that we need to export from our page file. The first one is named getStaticProps, which is used to fetch data at build time. And the other one is called getStaticPath. In this one, we're going to tell Next which path are they going to render. We're going to get those paths from .cms pages. We just need to export a function inside the page file named getStaticProps. That function should return an object with the props property. That props will be passed to the page component, of course, as props. In the context, we're going to get the route parameter for the page because we're using dynamic routes. If we had, for example, /folder1, we will get an object name with the property slug because it's the name of our file with the array of a string, the folder1. If we have /folder1, /folder2, we get the same slug but with an array of two entries, folder1 and folder2. Let's see how these functions work in our use case. So we just opened the slug file, and of course we have the component exported by default, but then we export the getStaticPath function, right? It's an asynchronous function. The first thing we need to do is we need to go to .cms and get all the pages because we need to create a list of pages to tell Next what pages it's going to build. So we create this utility, and inside what we have is we have a GraphQL query. We're using GraphQL API from .cms, and we're telling, give me all the pages inside the folder store. And give me the URL map, the URL, the folder, and the folder path. Some pages in .cms, instead of coming with a URL, come back with a URL map. For example, the product detail pages. Then with that data, what we do is we filter a few things, and then we just return, if the page has the URL map, we return the URL map. If not, we return the URL. Now let's see how these apply in our use case. So we open this log file, and of course we have this, the default export is the component, but then we also export it in the getStaticPath function. The first things we do is we need to fetch all the pages in .cms and get the URLs, because those URL is what we're going to use to tell Next, hey, build me these pages, right? So we create this little utility function, and what we're doing here is we're using the .cms API, GraphQL API, and we're telling them, give me all the pages inside the store folder. And we're telling them, give me the URL map and the URL. URL map are for detail pages, and URL are for regular pages. Then we just return one or the other, right? With that function, we're gonna get an array of URLs, right? An array of paths. But then we need to turn that array of path into a collection of objects with the property params, then a slug, and then the URL itself, because that's the required format for tell Next, hey, build these pages. We do that using this function. We just pass the array, and it's going to give me back a collection of these objects, right? Then Next will statically generate, in this case, for the example, destination /store category, and so on for all the pages, right? And it's going to use the component, the slug. So to do that, we need to return from this function the path, right? And the fallback false, what it's going to do is, if the URL doesn't exist and we ask it to Next, it's going to give me back a 404, right? That's what it does. But, and this is a really important but, if we turn this into true, Next have a special behavior. And what it does is, if you ask for a page that doesn't exist, Next is gonna run and gonna try to regenerate that page, right? Not in build time, but in production. He's going to try to build that page using the getStaticProps function, right? We're going to definitely look into that further in this webinar. So the first function that gets executed is this one, and then it gets executed the getStaticProps, right? In the getStaticProps, we can get the slugs that we're returning here. So we're going to get destination, a store categories, no, and so on, right? We get that slug, we turn it into an URL, and then we're going to get the page object from the page API in .cms. We just need the URL for that. So we create another utility function, and basically what this is doing is it's using our .cms library that is published in npm, and it's saying, hey, give me the page for this URL. So that's going to return me the page render object that we look into in the first part of this webinar. And what we're doing with this transformer page function is the containers and the contentlet, we're appending into the layout property. So when we render this in React, we don't have to, every time we get into a container, we have to go look for that in the containers property. We just append it into the layouts and we get it from there. If there is an error, we catch it here and we just throw it. Errors could be stuff like you don't have the right token for authorization, the page in a 404, or there is a instance of dotCMS is down, stuff like that. So once we get that, we get the navigation. Basically another dotCMS API that will give you the href, if you have children, the folder, all the information. And we're returning that as props, right? And with that, we're going to receive that in the component, page render and nav, but also we can receive an error. We're wrapping all this in a try catch. If there is an error, we only return the error. So basically what we're doing in the component is if there is an error, render the error component, but if not, render the .cms page. That is the component that have all the layout, the grid, the rows, the column, and everything. And we're passing the page render and the navigation, and that will render our pages. So with one file in Next, we're going to render any page in .cms, no matter if it already exists or if it's a new one or anything. We're using one file, so we don't have to create inside the pages the same routes we have in .cms. Now I'm going to run next build so I can show you how these pages are generated. So in the terminal, I run yarn build. Let's give it a second. Okay, as you can see here, Next is telling you with this log file, I generate this page, this page, this page, and 66 more paths. And it's telling you with this dot that is automatically generated static and JSON because it used get static props. Now let's run this and see how it works. So now Next is running in localhost 3000, the production build we just made. So if we go to localhost 3000/store, because are the pages we're building, boom, we render this. So you can see it was pretty fast. If we go to one of the detail pages, boom, pretty much instantaneous. Super fast, static generated pages are really, really fast and really good for SEO. Okay, we have 4 categories: snow, outdoor, water, and apparel. These categories are coming from .cms pages as well. So if we go to the browser portlet, you can see that we have inside the store folder, we have a category folder with apparel and the index page, outdoor, snow, and water. This menu right here, we're fetching it from those pages there. So if I go to outdoor, you can see it's pretty fast. Also because this is a static generated page. But if I go to climate, you can see it takes a little while and then it gets rendered. And check the URL. Now I have the climate. So the URL is basically a combination of outdoor, which is the category, and climate, which is a tag in the product. Let's try another tag. Let's try camping. So as you can see, it takes a little while. Now it gets rendered. And now let's try to go back to climate. Boom, super fast. As you can see, the first time it takes a little while to render, but then it's very fast. But how this is happening if we don't have an outdoor dash climate page in our system, in our .cms system? Well, let me show you how we achieve that. We created a second slug file, but this time inside store/category. We don't need to catch all, we just need to catch what is coming to /store/category. So we have the get static path, but instead of getting all the pages, we're only going to get the pages that are inside store/category. Then we create the path, we pass it here, and we pass the fallbacks through. By passing the fallback through, what is happening is when we ask for the page /snow, it's already created on build time. That's why the page loads really fast. But if we go /snow dash attack, you can see I showed you that it loads a little bit slower. And then if you go back to that page, it's load really fast. That's the fallback is for. Next.js, the first time you ask it, is going to build that page, it's going to save it, and then when you ask it again, it's going to load really fast. Then basically creates a new page. It needs to pass here. We get this log, and now this log is snow dash something. That's why we're splitting this log by dash. We're getting this first section, which is the category, and then we're getting that page from there. Now let's see what that page have inside. How do we render the product list? So if we go to snow and we open the index, we can see here that we have the banner, which is this banner right here. Well, let's go to snow just to see the same thing. So we got this banner, enjoy winner, right? And we got a product list, which is this section right here. This product list is not a content list. It's a special type of content in dotCMS called widget. And basically you can create it the same way you create a content type. So this widget is named store product list and have some fields like how many items do you want to show, the image width of the product, what type of content you want to show. So let's go back to the index page in the snow. Let's edit this. And we can see here that this is the widget title is snow. We want to show categories. We want to show products for snow. We want to show 10 of them. We want to, the image width, we want to be 250, and the image height we want to be 250. And we want to show the title, the image, the price, and we want to show tax filter. So what has happened there is that when we start rendering the page, we get into the contentlet, and the contentlet have all those as a props. So if we go to a store product list, which is our React components that map that widget, that content type, inside we got a product list component, and we get the quantity, we get the show tax filter, which has the fields we are passing from here, right? So we got the width and the height. And with this, basically what we're doing is we're creating GraphQL query, right? We're saying, okay, the content type is product because we want to render a product list. The categories are coming here. We're getting the categories. We're passing the categories. And also if we have tags, we pass in the tags. Then we pass that query with the options, and we just print out our product grid. So what is happening here is that because products are items or are contents that can change, it means you can create a new product in the category snow, but we don't want to rebuild the page snow. These sections right here, all this section is fetched client-side using GraphQL. So if you throw new products or you change the name or something right here, these sections will be always up to date. To wrap this up, let me show you how do we map each content type in dotCMS with a React component in Next. So let's revisit this dotCMS page component, right? That it takes our page render object as a prop. Remember that a page render object contains all the page information, which include the layout, the containers, the contentlet, etc. So if the page is a detail page, it will contain this URL map property, right? Like a product detail page will contain this URL map property. If we have that, we render the single page component. But if not, it means it's a regular page, like a category page, it renders the layout grid. So inside a layout grid, we start iterating over the rows in the body, and for each row, we render a row container. So inside the row container, we iterate over our columns, and for each column, we render a column container component. Then inside the column container component, we iterate over the containers, and for each one, we render this contentlet container component. Then inside the contentlet container component, we get all the contentlets, right? And we iterate over them and start rendering this contentlet component. At this point, this contentlet object is the content information itself. It's the instance of the content type, right? It could be a product, it could be an event, a news item, it could be a widget, right? A .cms widget. So with that, we pass that as data and we get it here in the content-led component. We have this util get component function, right? Where we pass data.content type. Data.content type is the name of the content type, right? It could be product, it could be news item, whatever you create in .cms as a content type. So if we open this, what we have here is we have a map of the components, of the React components we create for each content type, right? For example, we have the banner one. So the banner one receive the fields from the banner, right? The button text, image, caption, link, text color, title, etc. And with that item, with that properties, it start rendering, right? So if we have a title, we render an H1 with a title. If we have a caption, we render a paragraph with a caption. If we have a button text, we render the button with the text and the link, right? If we have an image, we render the .cms image component, right? So here, if the content type is banner, what this function is going to return is the banner component, right? So in content-led, this component here ends up being a banner component. And that's how we map each content type in .cms with a React component in Next in order to render those components and make it look really nice in a page.
We're going to open up for questions now. Thanks for joining this training. We hope it was helpful. Please reach out to me if you would like to discuss and schedule a tailored training for your team.